Hi BP, my name is Bob Backstein. I've invented a couple of devices that will aid in shutting off the BP oil spill, and I believe that these will make it possible. The first device is a clamp, the other is a shutoff cylinder device, and the other is a emergency fail-safe shutdown device, which I'll briefly explain here. This is the clamp, shaped like a clam. It has a hinge here. It opens up. It can be mounted on this BOP flange, the blowout preventer flange, while the product is flowing. It's designed to be mounted without any interruption to product flow, which is ideal for a high pressure situation like this. Once it's mounted, it can be bolted together. This flange is made of a hardened metal with a softer metal on the inside, so that the soft metal can seal around the flange and also can seal around the outside edges of this clamp. This clamp is cone shaped, shaped like an increaser, so that it can be put on without interrupting the flow of the product here. Other devices that I've seen don't do that. This can be built on a model above sea level using impressions. I'll talk about impressions. An example, when you go to the dentist and they put the tray of goop in your mouth and make an impression of your teeth, the same type of technology can be used to make this clamp. This is a picture of the clamp down at the bottom in the process of being married to this shutoff cylinder. What's unique about this device too is that we have a small nozzle orifice, is what we'll call it, on the BOP at the bottom, that's a lot smaller than the cross section of this cylinder, shutoff cylinder. That allows for a product to flow up through the cylinder as it's being attached. You can have a quick connect on the bottom of the cylinder, as well as a quick connect on the top of the clamp that allows for quick mounting of this device. Prior to pressurizing this cylinder and closing it, the bolts need to be bolted down to secure the closing cylinder with the clamp. We also have the landing hardware that helps to put these together prior to bolting. To describe the shutoff cylinder, we have an outside cylinder, which is the gray, and then which is closed at the top. It's open at the bottom. A valve can be mounted on top of that for product recovery. It has a window, an exit window, that lets the product flow out of it. Then on the inside we have the blue cylinder, the inner cylinder, which is open on the top and open on the bottom with these pushing rams that push the cylinder up. As it pushes the cylinder up, it closes the flow that's going through the exit window. When the cylinder is at the top, we have a seal that's at the top of the blue cylinder, and then another seal here that is part way down. So that gives us a seal above the window and a seal below the window to seal off the product. When the blue cylinder is moving up, we have a tapered edge here as it goes past the window, so that the seal is not damaged as it passes through the window. This device here can be mounted on top of the clamp as well, and it's an on-off valve that can be used for product recovery. It also has a defaults to the emergency shutdown position. Pressure from the flowing product pushes on this oversized piston that is a larger cross section than the cross section of the valve seat, which gives it mechanical advantage to close it. Now what we have on the inside here is a chamber that's a pressurized chamber, hydraulically pressurized from an external source. If that external source or the controller fails, this valve defaults into the shutoff position. Here's a diagram of the valve in operation. It's down here at the bottom. We have the ship above with this dotted line is the pressurized line. Anytime that line is severed, then we will have an automatic shutdown. As in this case, the line is severed and the valve defaults to the closed position. Thanks for taking time to watch my presentation.